Have you. Welcome everyone. Today we are speaking with Amir Feizpour. Thank you, Amir, for joining us.
Yes.
Amir, we are very excited to have you for AI agents, Lunch and Learn, AI agents that think, act, and collaborate. Amir is the CEO and founder at Aggregate Intellect. He is also a chief scientist. You work at Mars Institute and also a professor. You collaborate across multiple universities, conduct research on NLP, AI, and you have built a community of over 5,000 AI practitioners and researchers focused on AI research. And from what I'm seeing, you're running very technical rounds and boot camps on AI. You're an expert on AI agents. So welcome. It's great to have you.
Thank you. Yeah, thank you so much. Thanks for having me, and I'm excited to share uh, some of the things that I've been very excited about. So maybe I'll go through a few slides first, and then we can have a discussion.
Sounds good.
All right. So let me see how to share my screen. Okay, there you go. Okay, you can see my screen, right?
Thank you. Yeah.
Excellent. So yeah, I'm gonna say I'm gonna do a short presentation so that we can spend more time discussing. So the topic of AI agents has been around for a long time, but most recently in the past couple of years, because we have access to large language models that enable very sophisticated AI agents, the topic has resurfaced and has become much more interesting and part of the big hype that is going on right now. So I would say a lot of us are very excited about building software systems that are powered by agents. Especially, a lot of us are also very excited about building out systems that have multiple agents in them, and that is great. I think that's great news that a lot of us are excited about it. But the process of building agents is not as trivial as we would hope. So it is a complicated and nuanced process. And what I'm going to do today is touch on some do's and don'ts about building agentic systems and using them in the business context. So let's dive in. I'm gonna I'm gonna start by saying that you probably don't need multiple agents in your use case, and instead, what you need is better context management and good evaluation loops. This is the most important takeaway, I would say, from this session. If you don't remember anything else, this is what I'm hoping that you remember. You probably don't need multiple agents. You probably don't even need agents for your use case. What you need to think about is how do you manage the context in your software in a way that your business objectives or personal workflow objectives happen, and how do you evaluate to make sure that you're doing it right. That's the most important thing. Now you want to put a label of agents on it or anything else, that is the secondary consideration, right? So the functionality, like the reason that context management and evaluation loops are important is that those are the things that drive the functionality and usefulness of your application. And it is less about what you call it, and it's more about what it does. So if you're too focused on is this an agent or not, is it multiple agents or not, etc., you probably end up making poor decisions because you're just calling things agents that are not, and vice versa, while your focus should have been, am I evaluating this correctly or not? is the fact that it's not behaving correctly in these areas, like what is the reason for that, and how would I go about solving that problem? In most real world scenarios that I have seen so far, the decision to have multiple agents in a system is largely an engineering concern. So essentially, you have a problem that you want to solve. You manage the context as well as you can. You have your evaluation loops as good as you can set them up. And then at some point, you're like, I wish this would run in parallel so that I can have lower latency. You might break up the system in a few different agents and have them run in parallel to each other. Or for maintainability reasons, the same kind of reason that we would have multiple services in a traditional software. You would decide that, okay, this system is working as I'm hoping, but I'm going to refactor it to be multiple agents, multiple services, because that's more maintainable. That's easier to debug. That's easier to add to later, et cetera, right? So, and I can, go on and give you more examples of scenarios where you break up a monolithic system into multiple agents, the exact same way that you do with, software services, but a lot of that is engineering concerns. It's not like, for the functionality, we have to have 5 agents. Like, that's almost never true, right? At least in earlier stages of a product. The caveat on what I'm saying in terms of engineering concern is that sometimes you might prefer to have multiple agents in a system, although it is not functionally necessary, for reasons like operations, or risk management. So for example, it might be easier if you break up your software into 2 separate agents and one of them lives on this server, the other one lives on the other server, because that's better from a risk management point of view, for example, right? That's not an engineering concern, that's a risk reduction concern. But again, from a functionality point of view, it didn't need to be 2, but from a risk management point of view, it is better to have 2 agents in the system. Another reason could be marketing. Like, you might build the exact same thing as 1 agent or 0 agents, and it solves the exact same problem. You take it out to the market, you start talking to people, and they're like, meh. But then you start saying, oh, these are 2 agents that are interacting. And then all of a sudden, people are excited. Therefore, for marketing reason, you start calling things in your system agents, et cetera, right? So, again, like, what I'm trying to say is that in a lot of cases, you probably don't need agents. You probably don't need multiple agents. But, in some cases, you might need agents, and you might want to set up your system as a multi-agent system for, any valid reason, like what we talked about. But just make sure that you're clear with yourself about why you're calling a system agentic, if at all, right? But let's say you've done your homework and you are set up to build an agentic system for good reasons, and now you're going to go about it. And as I said, the important factors are going to be, how do you do context management for this agentic system, and how do you evaluate it, right? Like, these are the most important things that we have to do. So, but before we go there, I want to also bring up another aspect, which is, in most cases, we think about systems that we're building, AI-based systems we're building, and talk about, like, this is a question that I get often, which is, I'm trying to do blah, blah, blah. Is this an agentic system or not? So that is a binary question. And I dislike binary questions because they very heavily oversimplify what is going on. And something like agents, it's a complex question. You cannot just say, oh, it went above this threshold, therefore now it is an agent. Like, there's no such thing. The way I would like to talk about agents is to talk about agency and autonomy instead. And the reason is that that's a spectrum, that's a knob. Like, I can say, oh, for this use case, how much agency or autonomy does your system need? Because then you can say this much or a little more or a little less. Like, we can have a conversation that is nuanced and granular, rather than saying, oh, you didn't do this, therefore this is not an agent. Like, that is not useful. That's not interesting. But if you bring an application to me and say, for this use case, what can we do? I would say, okay, it looks like you need this much agency and this much autonomy in the system. And to give you the definition of these two terms, agency is the ability of the system to interact with an end user in a way that it feels human-like that's agency. Like if the system makes a decision and makes you feel like it is intentionally contributing to that decision, that is agency. Like how much of that does your system need? And autonomy is when the system goes on its own and does a bunch of things and comes back, right? So like you would say something like, find out, read my emails, figure out what meetings are necessary and book them, right? That's autonomy. Like the system will pick up your email, read it, categorize it, extract the entities from it, make some MCP calls to your calendar and books them. Like that's autonomy. The system is doing those on its own, right? So you already see the difference, right? Like in one case, it's all about how does the system interact with me. In one of the cases is, can this do things on its own, right? So autonomy is the continuation of automation, like RPA type of systems that we had. Now we can do them in a much more nuanced way. An agency is how much does the system interact with me? And in most cases, you need both. Like you need a little bit of agency and a little bit of autonomy to make the system, robust and interactive and interesting. So as we can see already, if we, shift our mindset from do I have an agent or not to how much interaction do I need to have in this system and how much does this need to do things on its own, you're already having a more interesting conversation, right? Because then you can say, oh, like autonomy is not that important. Like I want this to be a brainstorming system. Therefore, I would like it to interact with me. Or these are mundane. I do not look like interacting with them. Please get them done and come back to me when you're done. So you need a system that has more autonomy. So in terms of what's needed to set these up, these are completely different, set of requirements and nuances. And again, like in most cases, you need a bit of both. And over time, as your system gets more and more sophisticated, then the amount of each of these might increase as you get more data that you can use to train or fine-tune agentic behavior or autonomous behavior. The system gets more interesting and capable and expanded and blah, blah, blah. But if you just limit yourself to this thought process of do I have an agent or not, I don't know what knob you're going to turn to make it more interesting, right?
So Amir, maybe we should define what is an agent. An agent could be, your thermostat could be viewed as an agent. It regulates the temperature in your house. Let's say it goes over 22 degrees or something like that, it kicks up the AC. And if it goes under, it turns up the heat on itself autonomously. That is technically an agent. Now, in our context, we're talking AI-driven agents that are LLM-powered usually. They would have access to multiple systems, multiple APIs, potentially to talk to these multiple systems. You just mentioned MCP, which is a protocol. And an agent, I guess we can think about it as a piece of software with access to LLMs, maybe access to APIs, access to a memory, access to tools. And some of these agents could be acting autonomously. Other agents could be talking to other agents.
Yes. Like everything you said is correct. The problem is there is no threshold beyond which, because both of these things, they have amounts, right? Like how autonomous is it? How agentic is it, right? It's not 0 or 1. It is some amount. And I still have to see somebody who will come out and say, above this much autonomy and above this much agency, we're going to call it agent. Otherwise, we're going to call it the software system. That doesn't exist, in my opinion. And I don't think it is also a useful conversation to have. Like that's the whole point of what I'm trying to say. It is not a useful distinction. You have a problem. Does this thing solve the problem or not? It does solve the problem, great. But now you would like to also solve this other problem. How much agency would it need to have to do that? How much autonomy, additional autonomy does it need to do that? That's an interesting conversation. That's a useful, practical way to think about it. but just saying, oh, it's not an agent. Now what I did, that's not actionable. I don't know what to do with that. You see what I mean?
Yeah, let's focus on what it can solve and
Yes,
the business
absolutely. Yeah,
problem
100%.
that it's trying to solve. I
Absolutely.
was reading some research saying, well, when you have got multiple agents under the hood,
Yeah,
that makes it agentic. If you just have one,
yeah,
all of these things you can view them as agents,
yeah, yeah.
right?
Yeah, I mean, again, like I go back to what I said in the previous slide. I think like to the caveat that I gave, right? So there are a lot of reasons you would choose to call something an agentic because the user understands it better, or because it's better for marketing, or maybe the risk team in your company prefers it to be called that. Yes, absolutely. You should 100% do that. But from a functionality point of view, it's a useless definition in my point of view
Yep.
if you just say, oh, it is binary, yes or no, like it's not practical, it's not actionable, it's not going to help any sort of business metric to move. But if you
Exactly.
say, oh, we need to increase interactivity because it will, help your users engage more, and therefore it's going to impact our retention and therefore our revenue, like you can talk about it, like that's meaningful. Or if you want to say autonomy is necessary here because it's going to reduce the number of mundane activities that our admins have to do, therefore their bandwidth opens up to do more interesting client facing is like you can talk about it in a business context, but just saying is it Asian or not, I don't know what to do with that in the business context, or even like honestly in the research context. Like I don't know what to do with that information, right? Cool. All right, let's go. So how do you build agentic systems? You probably expect me to say something like, oh, you grab line graph and you do this class and that class and you have agents. No, unfortunately, that's not how you build agents, although vendors want you to believe that that's how you do it. So in my opinion, building an agentic software system is no different than an average, software products in general. So the way you go about it is that you pick a problem, you validate that problem, you build something minimal that is probably not agentic at all. You test it on the target audience, you iterate on it, you have some clear metrics, you measure those metrics, you iterate and iterate and iterate until you have some sort of a product market fit, and then you iterate from there to make it more interesting and sophisticated and expanded and blah, 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 right? That's exactly the same. That's what we've been doing for 2 decades or more, and that's still what we are doing here. So the process is the same. I know, one of the questions, Alina, you wanted to discuss was, should we use this framework or the other one? My answer is, I don't know. It depends on the use case. You most probably start from no framework at all with like simple LLM calls, see how far you
Yeah.
go, see how your evaluation metrics are doing. And then from there, you might layer in some framework that is suitable for that particular use case, et cetera, right? So
It, it, yeah, you're
essentially,
right. You're right. It is a very common discussion point across applications and businesses. Do we try a framework that, let's say, is no code or low code? And you have got multiple of those frameworks out there, from Zapier and 8N, a couple others out there. You also have got now no code systems completely, where you can just specify what you want. And at the other end of the spectrum, you have got LangChain and Python coding, and coding up the APIs,
yeah,
and multiple frameworks like Crew AI, AutoGen,
yeah,
and multi-agent collaboration. You have got things like MCP servers on top of all
yeah,
of this. So the business often starts to question. I mean, it seems very easy with
yeah,
no code tools
yeah,
to just set something up, but then for this to be enterprise grade, for this to be an application that is
yeah.
very stable enterprise grade, can we get away with these no code or low code tools? Do we have to go the route with the coding
Yeah.
and going deep into the weeds with the Python and everything?
Yeah, yeah. I think that's a slightly different question than where I was going, but yeah, 100%, that's a huge question, and we do hear that quite a bit. And my recommendation is start no code, even if you're a hardcore developer. The reason is like a no code tool like N8N allows you to prototype really quickly. And most importantly, it allows you to prototype in a way that is very easy to integrate into a bunch of things. And for most agentic applications, you want to have tool use, which means that you have to integrate it into a bunch of things. And yes, there are MCPs, we're excited about them, blah, 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 all of those things. But the reality is there are thousands of tools out there who don't have MCPs yet. So if you have a system that really simplifies integration into a bunch of tools that can easily bring in data, execute actions on behalf of your system, etc., that's a no-brainer to use it. So definitely for prototyping, my recommendation is almost always no code. And because you can just do that in an afternoon and integrate it into a bunch of things and do something very interesting. The good news about most no-code tools that we have access to, like N8N, especially something open source like N8N, is that you have the ability to also integrate it into coded systems. So if you start building this prototype and it's great and it's taking off and it's being used, and a component becomes the bottleneck of the performance because you need a more sophisticated system, you need a more dedicated hardware for it, whatever the reason is, you just grab that piece, take it outside, set it up on a different server, you write it in LangGraph or whatever, you optimize it as much as you want, you expose it as an API or MCP, and then the N8N orchestrator can call it, right? So you don't have to even be like this or that. It's going to be what hybrid system solves the business problem cheapest and most effectively. Right? Again, like it all starts from what's the problem? How do we solve it? How much agents and autonomy do we need? Then the question of how do we get there has many interesting questions. And almost it is never like definitely use this tool or framework and that's the best thing. It is not the case. Like these days, we have so much freedom to mix and match different technologies as long as they solve the core problem that we're trying to solve. Okay. Let's keep going. So what is this robust discovery process? So the robust discovery process, I call it minimal agentic interventions framework. I made this up. There are 3 components in this. Component number 1 is if you want to build an agentic system that meaningfully intervenes in a user workflow, you have to have a very deep understanding of that user workflow. You cannot be a random person from the street who just comes in and says, I'm going to automate lawyers, if you don't know anything about how lawyers work. You have to first really deeply understand how lawyers work, try to interact with them, watch over their shoulders. Again, like this is typical good old product development, right? Like there's nothing different about it. But it is more important than before because if you're building an agentic workflow that replaces, say, a lawyer's workflow, I don't know, accountant's workflow, a data scientist workflow, you have to understand what steps they take, what decisions they make along the way, and what good means in their context. Because if you don't understand those, you're going to build an agent that cannot execute that workflow. It's going to wave its hands and do a bunch of reasonable but inaccurate statements. Calculations and generations, and then you get a bunch of slop out of it. This is not useful for anybody, right? So you have to really deeply understand how a human will do this task in all of its complexities and nuances before you can get an agent to do that. Like that's principle number 1. And that is not something that happens overnight. You start by talking to a lot of people who do that activity. You really deeply internalize that, you build a prototype, you test it, and you iterate, and you iterate, and you iterate, right? So that's how the workflow understanding will happen. The second thing is that once you understand the workflow well enough to be able to replicate it using an agentic system, there are a lot of things that can go wrong in that system. And you need to have a very good framework, a very good loop to be able to measure if the system is working well and then feed back to it, right? Because otherwise the system can make an error, like especially if it is a complex workflow that are multiple steps and a bunch of branching logic, blah, blah. It can make a mistake in the first step and then that would propagate everywhere into your system, right? So that's bad. We want to prevent that. Or it might produce things that are okay, but not great. And then you count on them and you send it to a customer and the customer gets angry and you lose them, blah, blah, blah. Business impact right away in the negative way. So you need to have very good error analysis. And it is both from a software point of view, but also from a data quality point of view. If the system is generating a proposal for a customer, what does a good proposal look like? How do you measure it? What elements have to be present in it? How do you ensure those elements are present in it? What do you do when one of these elements is missing, et cetera, et cetera? So that error analysis and the feedback loop is super important to have. And that is honestly the most difficult part of building agents. You could build agents that give you okay results, but that's the difference. Like having the second point is the difference between great agentic systems and okay agentic systems. It's the difference between an agentic system you can throw together in an afternoon versus an agentic system that takes 9 months to build, right? That's the second one, because the first one has no error analysis, has no feedback loops. It's kind of sort of 90% there, but if you put it in a business context, the CFO will probably kick you out of the company, right? And 9 months later, with a lot of work to create evaluation data sets, feedback loops, blah, 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 you might be able to put together something that is business grade and is ready for production. And lastly, let's say, cases 1 and 2, you understand them, you're executing on them. It is not possible to just sit down and absorb a lot of information all of a sudden, create something that is perfect, right? Like the first thing you're going to create is probably going to be crap. And you're going to have to iterate on it. You have to start changing bits and pieces of it. Like, as I said, you might have to increase the agency by adding more interactions and human in the loop kind of back and forth. You might have to increase the autonomy by integrating in a few different systems and building an evaluation checkpoints that say, oh, okay, this is a good JSON packet, send it to the calendar, MCP, et cetera, right? So once you have those, you can increase the autonomy, et cetera. But the way you do this right without over-engineering is that every time you iterate on a system, you come up with the right scope of things that need to be changed about your system. Like, is it a little more agents? Is it a little more autonomy? Is it some engineering refactoring? Like, what needs to change about the system to become a little better, right? And that scoping is very important because you might make an observation using an early version of your product, agentic system, and then sit down and over-engineer a bunch of things for 2 weeks, and then see that, oh, that was completely unnecessary because I misunderstood what the user's feedback was, etc. So that is the the reason that I call this minimal agentic intervention is that essentially you figure out how the user works, you figure out how the user decides what's good, and you figure out how to add little by little LLM components to the system in a way that becomes useful for the end user eventually. I'm going to pause here. Does that make sense?
That makes sense. And agents, right? In these workflows, you are sending essentially prompts to these LLMs. That means your prompts are as important, maybe even more important. They're pretty much instructions and features to your agents. And one concern is that LLMs tend to hallucinate, or they might have misinformation or generate something that you may not want. And if you have got agents upon agents and LLMs upon LLMs, are you adding potentially more risk into the system? What are your thoughts on that?
Yep, that's exactly what I'm going to talk about next. So what Aditya said in the chat is exactly where I'm going with this, that I think frameworks matter less. The exact architecture of your multi-agent system matters less. A lot of the things that people say usually about how you get a good agent, they don't matter most of the time. What really matters is context management. Like if you don't manage the context of your system, then you have a bad agentic system. And that's exactly the difference between making an LLM call and having an agent, right? But that's one of the rare things that I can say what is an agent or not. A lot of the time, people think that I wrote at the beginning of my prompt that you're a good lawyer, therefore this is now an agent. That is not the case, right? An LLM call, by definition, is a stateless event. Like you just send the prompt, the LLM responds, that's the end of the story. And for a system that you can call an agentic system, it needs to maintain context in some way and form, right? And I can talk more about context management because you set me up for it. So, a lot of people, in the past couple of years have been very excited about prompt and prompt engineering and all of this jazz. And I honestly, personally never loved it until, this topic of context engineering and context management came up. Toby from Shopify was excited about it a while ago. And Andrea Caparti was very excited about it. A lot of us are very excited about it because that makes a lot more sense than just prompting. Because especially in an agentic application, what you're doing at all points during the workflow execution, if you have a good agentic system, is that you're managing the context. Like hallucination happens because the stuff that went into an LLM call did not provide the right context. It gave it some sort of, pieces of the context, and then the LLM is like, all right, I'm just going to guess the rest of it. So then you get a hallucinated response. If you manage the context well, then the probability of the LLM guessing will significantly reduce, and therefore you have a more reliable system. This is the formal definition I will throw at you for context management. So it is an orchestration of acquiring, retaining, shaping, and delivering the right information to the AI system at the right time so that it can reason and act effectively while maintaining alignment with user goals and expectations. This is a mouthful, but I'll explain what it all means very quickly. So when I say orchestration, what I'm referring to is essentially usually a software process that will essentially manage everything that is going on. If you're using N8N, that's the workflow you build inside N8N. If you're using line graph, it is the DAG, the graph that you build that says these are the steps and here's the branching logic and blah, blah, blah. That's the orchestration. It's saying at a high level what is happening in a system. And that's important as a context management component because that is essentially saying that the context starts here and then goes through the system in these steps. And every time you're either acquiring some new context or delivering some context, or you're reshaping the context that you have, or you're putting the context that we have into a memory so that we can use it in a different step, et cetera, right? But that's all of these 4 things that I mentioned here. Like you either are using a tool to acquire a context or to deliver a context. You're either deciding if a piece of information is necessary to be put in the long-term memory or just keep it in the session memory. That's the retaining part. Shaping, I just retrieved a bunch of things from my vector database. Do I need to retain all of this chunk information, or can I just summarize it to the most important piece because that's what I need to retain? That's the shaping part. If you put all of it in the context of an LLM call, you're probably going to end up with a subpar result, et cetera, et cetera. And the rest of this definition is stuff that we talked about and hopefully makes sense to you. So to give you a sense of what this means in reality, an agent could be executing a workflow like this. Again, like this could be line graph, this could be N8N, this could be Crew AI, Autogen, whatever it is doing something like this, right? And then let's say you're in this step of like the system is doing state management, which means that it knows that it has gone through all of these steps and now it is in this state and wants to execute this step. So it is very likely that in order to do this step, which is an LLM call, correctly, you need to gain context from a bunch of other steps or a bunch of other sources in your system. For example, in order to refine the document that is retrieved effectively, you might want to know, okay, what is the query? If I don't know what the query is, probably my summarization here is not going to be useful. If I don't know what other queries we looked for, again, my summary might not be useful, et cetera, et cetera. I might even need to know from a future step, like, what kind of summary is useful for the final answer to be produced, because I need to manage the context in all directions. So this is what context management is, and this is the majority of the time that is spent in building agentic systems is literally on, connecting these to each other and thinking, okay, is this better or not? And you make that judgment based on evaluation data sets that you create, hopefully. So it almost like the value, the gain that you will get from thinking about it correctly is significantly higher than, am I using line graph or autogen for this? Like that's a secondary consideration to me, because if you're not doing this right, it doesn't matter which framework you're using. It doesn't matter if you're using DS5 or not. It doesn't
How
matter if.
about how about we reframe that actually? How about if you are in a regulated industry?
Yeah.
If you work at a bank or a healthcare organization or insurance, I suspect certain frameworks would not be potentially allowed due to risks or regulations or compliance concerns, right? If you're running a small business, you might not be you might not be regulated potentially. You could leverage any one of these frameworks. But if you are in a regulated industry, I suspect the choice is definitely, you're going to be limited in what you could be doing and how you're going to
Yeah.
be setting these things up.
Yeah. I mean, that is definitely true, but within whatever your constraints are, hopefully you still have a couple of choices at least, right? Hopefully you could still choose between, do I use Autogen or do I write my own framework, right? At the very least, hopefully that is your choices. Like nobody's dictating to you that you definitely have to use line graph and nothing else. And hopefully that's not the case, right? If it is, leave that company, please. But you have a couple of choices at least. But if you obsess over that choice versus am I doing context management right, that's the problem that I'm trying to point out. Like if you just say, oh, I'm going to use this thing that company has whitelisted and hope for the best, that's where things will fall apart. Because if you're not thinking about this, like line graph, autogen, all of these things will give you the mechanics of context management. They will not solve your context management problem.
Yeah.
Your context management problem is solved by thinking very critically about what information is needed at what state in the system in order for that system to work effectively, right? Like that's what I'm trying to draw attention. Okay. I think that's pretty much it. Like I don't want to drag it much longer. Essentially, the way context management works in practice, again, like you could implement this in any type of framework that you have access to and your company allows you to use, as Alina said. But generally speaking, the system that you're going to build is going to have a bunch of software services like these white boxes and a bunch of LLM calls like these blue boxes, and data flows in a particular way in the system. And there's a bunch of user interactions like this gray box. And what really matters is how does data flow in a way that then it becomes available to this LLM call when it is about to happen, right? Like that's what I meant by the information has to be available, the right information has to be available at the right time, right? So you have to do this orchestration, like bringing everything together that I'm about to make this LLM call in my system. What information is necessary? How do I put it all together? And that's when the prompt structure comes in, because all of that information, you just stack it together in a prompt that hopefully goes to your LLM and execute that step correctly, et cetera, et cetera. So that's what Alina also pointed out earlier, or there was a comment in the chat as well, that the structure of what information goes into each of these LLM calls becomes very important, because that context is necessary to be there in order for the system to effectively work. And keep in mind that if you're building an agentic system, like this is a super simple agentic system. Like, I don't even call this agentic. Usually when you're building something agentic, it's more complex, has many more components. There are a lot of moving parts in it, and data is flowing in and out. And therefore, any error in any place will just amplify and propagate everywhere. So you have to be a lot more cautious about how you're evaluating things, how you're piping things together, how data engineering is so important in agentic systems, because all of the pipelines that I showed in the previous slide, the way they end up becoming part of a prompt that I'm about to send to an LLM as one of my LLM calls, all of that is like the typical data engineering pipelines that move data from here to there, write it to database, read it from it, write it to vector DB, read from it, et cetera, et cetera. And all of the good old data engineering. I wrote a joke on LinkedIn a few days ago that we are rebranding data engineering as context engineering, because that's what it is. Like, essentially, how does data move throughout your system as the bloodline and then come to the LLM calls in the right place at the right time to make sure that no error happens and no error propagates throughout the system. I'm going to stop here. Like, I have a lot more slides, but I'm going to stop here, and hopefully we can have some discussion.
So thank you. This was excellent. And if anyone has got any questions, do put them into the chat as we are gonna keep discussing. And one question that I think we should discuss would be around the value and the ROI, and aligning these agents for that business value generation. Many reports are saying that companies are failing to see ROI, get that value out of AI. And Accenture reports 20 to 45% productivity gains with agents. At the same time, you have got reports saying, well, businesses are not seeing that return on investment with AI. So hype, is AI all about hype, or maybe we are not choosing the right use cases potentially, or maybe not measuring them?
Yeah. I think there are problems at many, many, many layers, right? I'll give you an example. Coding agents. So coding agents make individual contributors super productive, right? Like they allow you, like Cursor and Cloud Code and such, Codex, they allow you to write so much more code. Like you could be like a semi-technical person like me, like I haven't written code in a few years now. You can make a semi-technical person like me contributing to the software code base. Although, 2 years ago, my engineers would yell at me if I tried to do that. But today it is okay because, I have Cloud Code that helps me write code. So there is like code generation has become such a solved problem. However, the bottleneck has moved from code generation to code review. So now the person that is code reviewing, the senior person in the team, is completely overwhelmed because they're like, well, I still have to review all of this. I can just approve, and then we're going to get a bunch of garbage in our main branch, or I have to properly review these. So efficiency has been created at the individual contributor level, but at organization level, we cannot see it because the reviewer is still the bottleneck. Like the bottleneck has moved from the contributor to the reviewer, but the bottleneck still exists. So yes, we are seeing productivity if you really zoom into the individual contributor, and if you zoom out and look at the organization, we're like, oh, so we are not shipping any more code than we were before. Unless you have like system level, organization level interventions that also allow the reviewer to do their job better, and then the operation team to do their job better, and then the sales team to do like the more you zoom out, the more teams are impacted by the higher rate of code generation. Now, are they adapting? Are they keeping up? Are they allowing the business revenue to increase, the cost to drop? So
Would it make
that's, I
sense?
think, the disconnect.
Would it make sense to still advise someone go and study coding? The World Economic Forum predicts that skills are shifting, and it's all about AI skills, learning AI, and they're saying it's going to be about no code. But does it still make sense to actually learn some coding?
I don't know how to answer that question, but I tell you what we do. So in the past year or so, when we are hiring a developer, we don't look for are they able to code or not. What we look for is here's a problem, use your favorite AI coding agent, build it, and show me how you collaborate with the coding agent. Show me how you criticize what the coding agent is doing. Show me how you find the bugs that it created. Show me how you verify that the tests that it wrote are meaningful. That's the skill set we're looking for. Like, can this person collab? And if the person doesn't have enough coding knowledge, they cannot do those tasks well. They're just going to vibe their way into it, and that's not useful for an organization. So I think, should somebody study coding? Probably yes. But the way they study, the skills they gain from it, I think, are going to be very different. The skills are going to be like, you're going to have a really good coding agent. How do you get the most out of it in the context of an organization?
That's actually very smart. Human and AI collaboration. I love that. As we're wrapping up this webinar, maybe one more question. What do you see as most transformative over the next maybe year or year and a half or so? This field is moving extremely fast.
Yes.
We have got, I don't know if you saw, there's JSON, and now there is a tune format to optimize for the tokens, right? So you don't consume that many tokens. We are now optimizing systems for agents, for LLMs. What are you thinking we're going to see over the next year or so?
A big part of the commercial work we do is working with organizations who are trying to answer this question. And I see two big trends. One is a lot of people are still looking for the right tool to get the job done. Like, they're asking, which tool should I use? And there is another group of people who are asking, how can we think differently as an organization, as a business, given that AI is coming and AI is going to essentially remove a bunch of organizational constraints we have? If I were to bet, I think the second group is going to survive in the next couple of years, and the first group is probably going to go away. The reason is that AI, especially LLMs and agents, they're so powerful that they're going to remove so many constraints from organizations. That means that the way you do business is going to completely change over the next few years. If you're ahead of that game, and if you're planning strategically for how do we enable people to do way more, to do more interesting things, to do more human touch related things, then you're probably going to be ahead of the curve to make the changes and adapt. Versus if you're asking around for, oh, do I use this tool or that, you're probably also going to die on that hill, is going to be my prediction.
This was excellent. Thank you. Thank you for attending, everyone. Thank you. This was very insightful. We are going to share the recording with everyone, and do follow us at www.aifutureleaders.com. Thank you, Amir Feizpour, for sharing your knowledge with us today. And thank you, everyone.
And feel free to connect with me on LinkedIn if you're interested to talk about any of these topics.
Thank you.